What we've got to look at now is how we can apply trigonometry to more real-world situations. And we're looking at angles of elevation, depression, and also looking at bearings. First off, let's look at elevation. It's pretty straightforward, elevation. If you're looking at something, and normally we think of using an elevator to go up. So if you're looking at something and there's an angle of elevation, it means instead of looking out straight, we're going to be looking up at something up high. So if I was, say, down on the ground here I am, and I'm wearing a dress. I'm not sure why I'm wearing a dress, and I've only got one leg these days. Anyway, and if I want to look at a little Tweety bird that's up here, it's a very pretty little purple Tweety bird, then to look at that bird, I'm looking up. I'm going to give myself two legs, and actually it's a kilt, so that's acceptable. Okay, I'm wearing a kilt. No, actually, let's just say it's my daughter. Okay, so that's an angle of elevation, and this is the angle of elevation in here. It's the angle from the horizontal, so whatever that angle is going upwards, that's the angle of elevation that we're looking at there. Okay, now if we look at the angle of depression, it's the opposite of that. Alright, so the angle of depression, maybe I'm actually on top of the harbour bridge, and this is going to stretch my artistic ability, but if I'm on top of the harbour bridge, and then, there we go, that'll do. Here I am up here, and this time I'm just a speck, and I wanted to be looking at the Opera House, which is down here, and I've really botched up the Opera House. Fortunately, our architects and builders are much better at building opera houses than I am. So here's the Opera House. Now, if I was to look out straight, then looking straight ahead like that, that's horizontal. But to look down to the Opera House is my angle of depression. So in that case, I'm on the top of the building and I've got to look down to the Opera House. So that angle in there is my angle of depression. And that's obviously the harbour across there. Okay, so angle of depression. Now the last one that we're going to look at here is bearings. So bearings are always taken from true north, due north. It's got a range of different ways of being expressed in textbook questions, but what it means is if you've got a compass, if you have a map, then we always measure from due north. We always measure the angle from due north, and the angles always are given a three-figure number. So if I wanted to think about looking over in this direction, then looking in that direction or travelling in that direction, so let's create that little angle there. If I'm travelling in this direction, okay, we might normally think of this angle here as being 40 degrees. Okay, we might normally think of it as being 40 degrees, but actually, with bearings, we say that this is point A and this is point B. We say the bearing of B from A is 0, 4, 0 degrees. Always three figures, 0, 4, 0. And the other thing is to remember that if it's the bearing of B from A, the from place is where you are. You're right here. The bearing of B from A, so is 40 degrees, so 0, 4, 0 degrees. Now we might go somewhere else too. We might want to travel in some other direction. Maybe someone took off in a different direction and perhaps it's over here. Let's go over here. Okay, and we'll call that point C. So now what we would say is it's the bearing of C from A. Again, from is where we're standing, and we need to now measure this angle here that goes all the way around to C, to that line there. Okay? Now, if you think about it, this is north is 0 degrees. That's 0 degrees. East would be 90 degrees. 90 degrees. South would be 180 degrees. West would be 270 degrees. So we're somewhere between 180 degrees and 270 degrees. So let's say maybe we're 210 degrees. It doesn't really matter for this. 210, maybe 240. Okay, we'll say we're on a bearing of 2C is a bearing of 240 degrees from A. From is where we are, and so we have to go the compass bearing all the way around to there. And we could do another one, a last one perhaps. Let's say we're looking at something that's right here. Now, I know that's very, very close to north. Oops, he's missed it. There we go. And we'll call that position D. The bearing of D from A, so again we start at A, so this time we're going to go all the way around to get to D. The bearing of D from A, in this case, I think it might be something close to 345 degrees. Okay, so we'll say it would be 345 degrees. Okay, now what we have to do is keep in mind that bearings are always measured from north. They're always 3 figures. And sometimes you'll have to do a little bit of addition and subtraction with respect to other points of the compass that you know. So let's put in some of those other points of the compass that you know. And the other points that, as far as we're concerned, are the key reference points, are that east is 90 degrees and that south is 180 degrees and that west is 270 degrees. So we keep those key reference points in our mind when we're trying to calculate the angles between one place and another. Then, once you've established those angles, we'll apply everything we know about trigonometry to solve the problems, find distances, find how far something's travelled, how far we need to travel, all those sorts of things that will come up in typical questions for high school textbooks. Okay, so what I'd like you to do is to get cracking with the exercises in your textbook and enjoy working with elevation, depression and bearings.